Okay, so today we are going to find the area of not right triangles, but pretty much any triangle now. We have to be given a certain set of conditions though. So let's talk about area of triangles. Make sure you guys are taking notes, right along with me. And if you have any questions, feel free to ask. So our basic equation, A is equal to 1/2 base times height, is our bread and butter of all triangles. In geometry, you learn how to solve them for right triangles, where one side's the base and one side's the height. We can also have drawn it in a funny way, but as long as we can find the height and the base, we could also find the area of that triangle. And these are a couple things that we practice in geometry. And this rule has not changed. In today's rule, it still is not going to change fundamentally. So our problem now is that if I give you guys a triangle that looks like this here, okay, and I don't give you the height, well, how do we find the area of it? So I'm going to give you guys a certain set of criteria. This is going to be what we call side angle side. I'll call this 3, 32, and 5. 3, 32, and 5. So it's going to be S, A, S. So for these type of triangles, SAS type triangles, we are going to have a rule called the sine formula. Sine formula for area. And this isn't really a rule, more of an observation. So here is our general format. It's going to be area is equal to 1/2 A, B, and what letter will you probably say next? A, B, C, right? You say C. But we're going to say sine of capital C, angle C. So you're always going to use letters, little letters that represent sides, followed by sine of an angle. And as you notice, I'm using A, B, C. Let's write a different version. A is equal to 1/2 B, C, sine. What letter am I missing? A. A is equal to 1/2 A and C. What letter am I missing? B. What happens is these are all SAS versions of each other. Now let me just draw a triangle with the letters A, little a, B, little b, and C, little c. If I am using angle A, that means B and C are right next to me. Look. So it's side, angle, side. If I was looking at angle B, then the sides I would use are A and C. I'm not going to use side B. And that's our ACB. If I'm looking at angle C, I can use this rule when I have the adjacent sides, A and B. So AB sine C. So let's go back to our problem before. Let me draw this again. A, which was 32. And then we give ourselves, we called it what? 5 and 3. So how would I use this area formula for this problem? We just say A is equal to, we write the sides, we'll call this B. No, let's call it the other way. Let's call this C and call this B. So 1/2, I see 5, I see 3, and we multiply sine of my angle 32. So this would be letter B, C, sine of capital A. So the letters really don't matter. It's the positions that matter the most. And as long as this is an SAS triangle, everything else is just calculator work. Now let me show you how fast this is on the calculator. Oops. On my calculator, I'm just going to type 0.5, because that's a fast way of writing 1/2, times 5 times 3 times 32 sine equals, and my area for this triangle is 2.4, let's round up, 2.47. When we write square, units, or unit squared, okay? You can write that too. Tell me, plugging that into a calculator is hard. With the amount of calculator work that we've been doing, this is not a hard problem. This is just a hard setup. Now let's talk about why this is true now. Quickly, let's talk about why this is true. Now, if I didn't have this rule, you would have done this. I'm going to draw this again on the right side. Let me draw this in red. If I didn't have this rule, and you were in geometry class, and you had learned how to use sine and cosine, you'd have written this. You'd have drawn a vertical line and call this height h. Okay? And then now that we have a right triangle, this is my opposite, and this is my hypotenuse. And we could use sine because I'm looking for my hypotenuse, but I do have my hypotenuse here. So sine of 32 is equal to h over 3. Remember our rule in geometry is a is equal to 1/2 base times height. Do we have the base? Yeah, the base was 5. Do we have the height? Nope. We can find that because the height is a calculator, 3 sine 32. Now here's what we're going to do. We're going to say b is 5, plug it in. We're going to say h is 3 sine 32. A is equal to 1/2 5 times 3 sine 32. And that's actually the same exact answer here. The sine formula for us we're using is just a defined definition way of writing what we would have already done in geometry. The height will always be represented by the angle and the hypotenuse. Sine of A is equal to h over, let's call that c, which gives us c sine of A. Plugging that into our formula, we have A is equal to 1/2 B C sine of A. Always going to work. So let's do this one more time. Let's take out your calculators, making sure that you can do it. Give you guys a problem. Call this 92, 10, and 6. Is this enough information for us to find the area? First, tell yourself, what type of triangle is this? Is this SAS? Is this SSS? Is this ASA? SAS? So we can use a rule. So A is equal to 1/2 base 10 times height, but the height is going to be made up of this sine function, 6 sine of 92. Go ahead, tap that in your calculator. Make sure you get the same answer I do. If you don't know how to type it, I'm going to write 0.5, makes it easier, save time, times 10 times 6 times 92 sine equals. I'm getting 29.98. Yep. Okay. If you're not getting this answer, you're probably doing something wrong with your calculator, but definitely ask me. I can take a look at your calculator right now. Okay, someone just told me I messed up my number here, and they're right. I messed up. The previous answer was 3.97. Yep, sorry about that. Thank you for double checking me. I don't know what happened. I typed something weird. Okay. 100%. Thank you very much. Okay, now you might say, well, isn't SAS kind of limiting? Like, what about if I get triangles in other shapes? What if I don't get an SAS triangle? So what if I give something like 32, let's do 5, oh, sorry, not 5, 36, and we'll give you guys a side 10. Is this SAS? No. So for this type of example, what could I use? Would I use law of sines or law of cosines to solve the triangle? Well, here's a hint. If I have two angles, can I find the third? So 180 minus 32 minus 36. We end up with 112. 112 degrees, great, but that's still not SAS. So now we have to find out one of the sides. So sometimes you have to do a little detective work before we're able to use these rules. This isn't the right triangle, so I can't even use the 1/2 base times height. So let's go ahead and find a side. That's all for, let's call this A. That's all for side A. So A over sine of 32 is equal to 10 over sine of 112. And we've done this on the calculator plenty of times. So on your calculator, why don't you double check me? I'm getting 5.71 rounding up. It's 5.72. So 5.72 on this side. Double check one more time. $5.72. Now we have our side angle side. So sometimes it might take us a couple steps to get there. A is equal to 5.72 times 10 times sine of 36. .5 times 5.72.
Sorry, Mr. Ko, you got a 5.72, right?
Yeah.
Okay, cool. Thank you.
I'm getting the area to be 16.81. Try that again. 0.5 times. Yep, 16.81. So this rule is super helpful, but I need a side angle side. I need to know this corner of information, and this rule works really well. Now our next rule today is called Herons Area Formula. Herons Area Formula. And this one works with specifically only SSS triangles, okay? Only SSS triangles. That's my crappy version of Superman, if you're wondering what I'm doing. Okay. So SSS means you know all three sides, no angles at all. So let's do an easy one that we know that's going to work. Let's try a 3, 4, 5 triangle. A 3, 4, 5 triangle. We know what the area of this is. It's half base times height. Area is 1/2, 4 times 3 is 6 units squared. Okay, 6, great, awesome, 6 units squared. Now, let's do let's use Herons area formula. Now, Herons area formula is written this way. It goes area is equal to, now careful, it's a square root of S, then S minus A, S minus B, S minus C. So what happens is you find out what S is, and then we minus it from every side we have, A, B, and C. Now, what is this S? This S looks like the average, but remember, it is not. I'm gonna tell you this, remember now, it's not. It is A plus B plus C all over 2. Not 3, not 3. It's 2. Get it into your thick skulls. It's 2. Herons is a lot more work, especially if your answer comes out as a decimal. If your S is a decimal, your writing takes forever. But the process isn't terrible as a process. So here's what we do. We take our S. To find S, we say add up the 3 sides. 3 plus 4 plus 5 and divide that by 2. 3 plus 4 is 7 plus 5 is 12. 12 divided by 2 is 6. And now we plug into this formula. A is equal to the square root of 6 times 6 minus 3. Then 6 minus 4. Then 6 minus 5. If you want to save time and S is a regular number, a whole integer, you can just write 6 times 6 minus 3 is 3. 6 minus 4 is 2. 6 minus 5 is 1. And you could do this to save time. A is equal to the square root of 36. And that just gives us 6, which is our answer from our traditional way of doing it. So great. Awesome. This is super easy to do, right? Why am I doing it? Because most of our answers, most of our triangles are not going to be right triangles. And if I do give you 3 different sides, no angles, this is the best way to do it. So let's go ahead and do a problem that isn't as simple. Here we get some space. Call this 10, 8, and then call this 7. Actually, you know what? Let's call it 6. Make our lives easier. 6. Okay. 6, 8, 10. Sounds just like another right triangle, perhaps. So our S value would be, since we know side, 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 we're going to use herons. So use herons. So S is equal to 6 plus 8 plus 10 over 2. That gives us 24 over 2 is 12. Then we write our A value. Our area is 12 times 6 minus, 12 minus 6, 12 minus 8, and 12 minus 10. Or you can just write the square root of 12 times 6 times 4 times 2. And that's going to be some fat number, 576. When we take a square root of that, gives us the answer 24. Now, let's do one with a decimal. We'll say 5, 6, and 7. Will there be a decimal here? Maybe not. S is equal to 5 plus 6 plus 7 over 2. That's 18 over 2. Is it 18? Yeah, 18 over 2. And that's going to be 9. So A is equal to square root of 9 times 9 minus 5 is 4. 9 minus 6 is 3. And 9 minus 7 is 2. That's the square root of 216. And the square root of 216 is 14.6969338. We're going to round up. Areas is 14.70 units squared. Okay. That's Heron's area formula. That's how we find the area of these two different types of triangles.